Lesson 10. Angle problems and solving equations. So angle facts and definitions. We need to observe some different angles. First, adjacent angles. Adjacent angles are angles that share a common side, and they are right next to each other. For instance, in our diagram here, we have angle BAD, angle bad, and there's a common interior ray, C, the common side AC, and that makes the two angles BAC and CAD adjacent angles. So angles lowercase a and angle lowercase b are also considered adjacent angles in this case. So we have a couple names for these angles. We could name it BAC or A, it as C, or we could label the other one CAD or B. So two different angles, two different names for each because of the diagram. Vertical angles. For vertical angles, as we see in the diagram, we have two lines that form an X. The X can be as narrow as we want, or as wide as we want. No matter how narrow or how wide we make this X, the opposite angles will always be the same. There is nothing that can change that. So, angles A and B are equal. We could also say angle DCF is equal to angle GCE. We could say angle DCG is equal to angle FCE. They are vertical angles. They are vertically opposite angles if their sides form two pairs of opposite rays, and they do. Next, angles on a line. Angles on a line. A straight line is 180 degrees. So any angles added together to make a straight line add up to be 180 degrees. So angle A and angle B in this diagram total to be 180 degrees. Angles at a point. So here, in this diagram, angles at a point, the point is A, capital A. At this point, if we were to sum all three angles, B, A, and C, we would get 360 degrees, because a complete circle around a point is 360 degrees. So we could say A plus B plus C, or we could say BAC plus CAD plus DAB equals 360 degrees. So some very important vocabulary for the problems to come. So first, name the angles that are each of the following, and we want to find which pairs would make vertical angles. So first, the first pair, AEC and BED, make vertical angles. They are the exact same angle. They're connecting with opposite rays. They are vertical angles. The next pair, CEB and DEA, would also be vertical angles in this case. We could verify this by taking 79 and 48, adding them together, 90 and 37, adding them together, and we would get the same thing. We would get 127 degrees. Angles on a line, adjacent angles. Adjacent angles would include, and there are multiple answers here, AEC and CEF, AEC and AEG would also work, CEF and FEB. We could do FEB and BED, We could do BED and DEG. There's multiple answers that we could do. Angles on a line. So angles on a line, these are angles that would form 180 degrees if we added them all together. So first, if we added BED, DEG, and GEA, so this angle, and this angle, we get a straight line. We get the line AB. That's 180 degrees. If we add AEC, DEG, AEC, CEF, and FEB, we would also get 180 degrees if we add up all of these together. Another one we could do CEF, FEB, and BED to get another 180 degrees as well. Next, angles at a point. If we added up all the angles together, every single one, we would get 360 degrees. So example 1. We are looking at two angles that would combine at angles on a line. So angles on a line. So first, let's estimate the measurement of x. What should x be in this diagram? And so in a complete sentence, we're going to describe the angle relationship in the diagram. Well, first, angle BAC and CAD are angles on a line, and they have a sum of 180 degrees because they form a straight line when added together. So to solve this, we're going to write an equation for the angle relationship shown. We're going to solve for x. And then we're going to confirm our answer, measuring the angle with a protractor. So first, x plus 132 equals 180. That's our equation. If we add the two angles together, we get 180 degrees. So now we want to solve for x. To solve for x, we want to get rid of 132 from the left side. Well, the opposite of adding 132 is subtracting 132. So we're going to subtract 132 from both sides. And we will have x equals 48, because 180 minus 132 is 48. So the angle measure for x is 48 degrees. So the measure of BAC is 48 degrees. And that's our final answer. Exercise 1. In a complete sentence, describe the angle relationship in the diagram. And they have a sum of 180. Now observe this little square here. That means we have a right angle. So CAD is a right angle. And a right angle will always measure out to be 90 degrees. So here, our equation is going to be 3x plus 90 plus 2x equals 180. So 3x plus 90 plus 2x equals 180. We combine like terms. 3x and 2x make 5x. We have 5x plus 90 equals 180. So we're going to subtract 90 from both sides of the equal sign. So subtract 90 from the left, it cancels itself out. Subtract 90 from 180, and we get 90. So our equation is 5x equals 90. To simplify, we're going to divide both sides by 5 or multiply by 1/5. That eliminates the 5 on the left side. 90 divided by 5 equals 18. So x equals 18. We're not done yet. We have to find the measurements of angle BAC and angle DAE by plugging in 18 for x into both expressions. So 3 times x, or 3 times 18, we get 54. 2 times x, 2 times 18, we get 36. So the measure of BAC is 54 degrees. The measure of DAE is 36 degrees. Example 2. In a complete sense, describe the angle relationship in the diagram. This one looks like an X. This one looks like an X, which means vertical angles. So opposite angles are equal. So AEL and LEB are angles on a line and have a sum of 180 degrees. AEL and KEB are vertical angles and are equal of measurement. So to find y is going to be equal to angle AEL would give us. To find x, we use angles on a line. So 144 degrees plus x equals 180. So we have two different things that we're solving here. So first, y equals 144 degrees. Why? Because of vertical angles. Y, or KEB, is equal to AEL. It will always be equal because of vertical angles. So y, 144 degrees. To find x, we're going to take x plus 144 equal to 180. We subtract 144 from both sides of the equal sign so that we solve for x alone. Well, x then must equal 36 degrees. And we can always verify this. Plug in 36 to the original equation. 36 plus 144 equals 180. So x equals 36 degrees. So therefore, the measure of angle LEB is 36 degrees. Exercise 2. We have more going on in this problem. So in complete sentences, we're going to describe the angle relationships in this diagram. So first, we want to observe it carefully. We're not given any information about MEL. We're not given any information about JK. However, JEN and NEM, they're adjacent. They're adjacent angles. And when added together, they are the measure of JEM. JEM and KEL are vertical angles. And how we know this is by the diagram, by the lines. Line KM, line JL. You know that by lines. That makes JEM and KEL vertical angles, so they must be equal in measurement. So what's that mean for us? We can set up our equation with certainty. 3x plus 16 equals 85. JEM to KEL. Well, KEL is 85 degrees. JEM is 3x plus 16. So now we're ready to solve for x. We want to get x by itself. So first, subtract 16 from both sides. When we subtract 16 from both sides, we get 69 on the right. 3x is left over on the left side. Divide both sides by 3 or multiply by the multiplicative inverse of 1/3. X equals 23. Is that our final answer? Well, we're getting closer. So x equals 23. So x equals 23. Example 3. In a complete sentence, describe the angle relationships in the diagram. Well, first, we have GKE and EKF and GKF. They're angles at a point, and they have a sum of 360 degrees. If we add up all three of those, we get 360 degrees, because we can make a complete revolution around. So that means all three added together get 360. GKE is a right angle. It's 90 degrees. So to set up our equation, x plus 90 plus 135 equals 360. We'll combine like terms. 90 and 135 make 225. We then subtract both sides by 225 to get x equals 135 degrees. So x equals 135 degrees as well. So then if we were to look at just labeling it in a different way, instead of x, EKF, the measure of angle EKF is 135 degrees. In this diagram, we could say either name. We could say x or EKF. Exercise 3. We have the following points. These angles are at a point. They all surround A. So if we were to sum all these angles together, we would get 60 degrees. So let's set up our equation. We have x plus 1 plus 59 plus 103 plus 167. So now we want to combine like terms. Well, first, there's nothing in front of those parentheses that will change x or 1. Because we're only adding, there's no subtraction, there's nothing to distribute, so we could just drop the parentheses. And now we can combine like terms. If we combine like terms, add everything together, we would get 330 on the left side. So x plus 330 equals 360. Subtract 330 from both sides, we get x equals 30. So the measure of GAH, the measure of that angle, is 30 degrees plus 1 equals 31 degrees. Example 4. The following two lines intersect. The ratio of the measurement of the obtuse angle to the acute angle in any adjacent angle pair in this figure is 2 to 1. So in a complete sense, describe the angle relationships in the diagram. They are vertical angles. We have some vertical angles in here. Example 4, the following two lines intersect. The ratio of the measurements of the obtuse angle to the acute angle in any adjacent angle pair in this figure is 2 to 1. So in a complete sentence, describe the angle relationships in the diagram. So here, the measurement of an obtuse angle is twice the measurement of an acute angle in the diagram. So 2x and x. So 2x and x means if we were to combine those together, we would get a straight line. We'd get 180 degrees. So 2x plus 1x equals 3x. So 3x equals 180. Next, we divide both sides by 3 or multiply by the multiplicative inverse of 1/3. That gets us x equals 60. So x equals 60. That means the obtuse angle is 120. So x equals 60, that's the acute angle. Obtuse angle is 2 times the quantity of x. So 2 times 60, which is 120 degrees. Exercise 4. The ratio of angle GFH to EFH is 2 to 3. In a complete sense, describe the angle relationships in the diagram. So observe, we have this little box in the corner that means GFE is a right angle. GFH and HFE are adjacent angles, which means these angles added up would equal 90 degrees. So 2x plus 3x equals 5x, so 5x equals 90 degrees. We divide by 5, x equals 18. Or multiply by 1/5 to get x equals 18. So if x equals 18, now we can solve for the measures of both of those angles. 2 times 18 is 36, so GFH is 36 degrees. HFE is 3x, so that would be 3 times 18, which is 54 degrees. So exercise 4, find the measures of angle GFH and EFH. So first, we have this right angle, GFE. GFE is a right angle, which means 2x plus 3x equals 90 degrees total. So 2x and 3x make 5x. 5x equals 90, so divide both sides by 5 or multiply by the multiplicative inverse of 1/5, and we will get x equals 18. So to find the measure of angle GFH, we plug in 18 for x. 2 times 18, we get 36. To find EFH, we do 3 times 18, we get 54 degrees. The next important thing we're going to discuss, just briefly, is the vocabulary that was discussed in this lesson. And you will see this on your next quiz. First, adjacent angles. Two angles, angle BAC and angle CAD with a common side AC, are adjacent angles if C belongs to the interior of angle BAD. That is very important to note. Vertical angles. Two angles are vertical angles if their sides form two pairs of opposite rays. Very important. So think of the X. Vertical angles, think of the X. It can be as narrow or broad as we like. Angles on a line. So angles on a line, you have a straight line, different angles that make up that line, they're going to add up to a total of 180 degrees. Finally, the last one, angles at a point. So angles at a specific point, the distance all the way around would be 360 degrees. Thank you so much for tuning in. Have a great